students. So those who have not subscribed my channel, please subscribe my channel and also share my videos. So let us start with another topic of electrical engineering, which is equivalent circuit of the transformer referred to the primary side. We have already seen the working of a transformer. We have already seen the equivalent circuit of a transformer. Now we have to see what is the equivalent circuit referred to the primary. In this lecture we are going to learn. Okay, so what do you mean referred to the primary? Actually, this is the whole complete equivalent circuit shown over here. This is the primary side shown over here. Primary side is having the primary resistance, primary reactance, the voltage V1, current I1, and the current is having the two components, the no load component and the load component of the primary current. Okay, so again the load current is having two components, the magnetizing component I mu and the core loss component IC. Then the resistance, it can be denoted by R naught, giving the denotation for the no load, or can be denoted by RC, as well as this reactance can be denoted by XM or X naught. X naught is representing the no load reactance. Okay, so this is the primary side and this is the secondary side. At the secondary side, the EMF E2 is being set up and the resistance is shown over here, the reactance is shown over here, the current flowing I2 and the load by the impedance ZL is shown over here. Now these are two different circuits actually. This is the primary circuit and this is the secondary equivalent circuit. So we want a circuit which is referred to the primary. When I take all these components that are the resistances, reactances, currents and voltages to the primary side, then my equivalent circuit becomes the equivalent circuit referred to the primary. If all these are taken to the primary, then it becomes referred to the primary. Okay, and if I take the primary resistance, primary reactance, the primary voltage, primary EMF, primary current to the secondary, then it becomes referred to the secondary. The equivalent circuit of a transformer referred to the secondary we will be learning in the next lecture. In this lecture we will be learning how these secondary resistance, secondary reactance are taken to the primary side. Okay, so for that, one important term you should know, that is the transformer ratio. We already know what is transformer ratio. Transformer ratio is given by K, or in some books it is also denoted by A. What it is actually? Transformer ratio is given by V1 upon V2 is equal to I2 upon I1 is equal to N1 upon N2 is equal to K, or you can also say A. In some books it is given by A, in some books it is given by K. It is just a constant you can denote by with any alphabet. Okay, with any constant you can just denote it. So the transformer ratio depends upon the number of turns. Number of turns in this equivalent circuit are given by N1 and N2. Okay, so it is depending upon the number of turns, and N1 upon N2 is the ratio that is being given by K, and it is equal to V1 upon V2, and it is also equal to I2 upon I1. Okay, so now when we will refer these currents, resistances, impedance, so there are three rules over here that it has to be followed actually, because it is depending upon the transformer ratio. So all the secondary resistances and reactances are reflected to the primary as the square of the transformation ratio. So it has to be done square. Whenever my resistance and reactance, they will be shifted to the primary, then the square of the transformation ratio will be multiplied with it. That means whenever my R2 is shifted to primary, then with it K square will be multiplied. So whenever it will shift to the primary side, the value of R2 will become K square R2. The value of R2 will become K square R2. Also, the second point says all the voltages reflected from secondary to primary directly as product of the transformation ratio. So whenever the voltages will be shifted to the primary side from the secondary, whenever they will be reflected from the secondary to the primary, they will be directly as the product of the transformation ratio. That means my V, that means my V2, whenever it will be shown or it reflected to the primary, it will be K times V2. Okay. It will be K times V2. Okay. Then third point is all the currents are reflected to the primary from the secondary inversely as the transformation ratio. So they are reflected inversely. Inversely, that means I2, all the currents, whenever they are shifted to the primary side, then it will be, the value will become I2 upon K. Inversely as the transformation ratio. Inversely as the transformation ratio. So we will be following these three rules. These are very much important. And why this is happening? This is happening because my transformation ratio is given by V1 upon V2 is equals to N1 upon N2 is equals to I2 upon I1. Okay. So now let us start drawing the equivalent circuit. It referred to the primary side. Okay. So let us start drawing. Primary will remain as it is. This is the voltage source. Primary will remain as it is. Primary resistance R1. Primary reactance X1. The no load current having the two components RC or R0. In some books it is given by R0, so I have denoted both the variations over here. Okay. XM or X0. Okay. This is the no load current. Here the primary current I1, the voltage V1 over here. Okay. This is the primary. Yeah, we have to refer it. Okay. Okay. Now this R2 has to be shifted to primary. This R2 has to be shifted to primary. So R2 is the resistance. So the R2 value now will be becoming now R2 into K square. So my resistance here will be KR2, K square R2. K square R2. Okay. This is the primary side only. The secondary resistance and reactances are shifted to the primary side. Okay. So now this is my reactance. This has to also be shifted to the primary side. So it will become K square X2. K square X2. Okay. So now this is my load ZL, that will be also K square times. And so it is complete. Now here I have to show my E1 will be equal to E2, but E2 will be K times, because E2 is the voltage or the induced EMF. It is the induced EMF and it will be directly proportional to the transformation ratio. So it will be K times E2. So it will be K times K times E2. Okay. Then the current, the secondary current will be I2 upon K, because the secondary current is inversely as the transformation ratio. So secondary current will be given by I2 by K, will be given by I2 by K over here. Okay. So this is the equivalent circuit of a transformer referred to the primary. Now this equivalent circuit is known as the exact equivalent circuit. It is known as the exact equivalent circuit. What it is known as? The exact equivalent circuit referred to the primary side. It is known as the exact equivalent circuit referred to the primary side. Now this no load current is to be represented over here. This no load current is very small. It is about only 2% of the full load current. It is only no load current I naught is only about 2% of full load current. Okay. And the impedance R1 plus JX1 is negligible on account of no load. So this can be shifted before this, before R1 and X1. This can be shifted before R1 and X1. So let us draw the equivalent circuit in such manner also. So this is voltage source. First we have to draw this. This is known as the shunt component, having the shunt resistance and reactance are in parallel to each other. That is the shunt component part. Shunt part. Okay, so I have shifted. This is R1, this is X1, this is K square R2, this is K square X2, and here is the load, that is ZL K square. Okay, so these are my RC or R0, and this is XM, or I can also say X0. This is the no load component. So when I will shift it before my resistance, primary resistance and primary reactance, then there will be no effect on the currents. There will be no effect on the working component of the no load current, and as well as the magnetizing component. This is I mu. This is the core loss component or the working component, and this is the magnetizing component. There will be no effect on it. So this circuit, this equivalent circuit is known as the approximate equivalent circuit. This is known as approximate. This is known as the approximate equivalent circuit. Okay, so now we can easily calculate the RE1, equivalent 1. RE1 will be equal to R1 plus K square R2. In the place of K square, we can also write N1 upon N2 whole square. because N1 upon N2 is the transformation ratio equals to K. Okay. So RE1, why? It is a R equivalent referred to the primary. So that's why we are putting the 1 as a 1 over here, suffix over here. Okay. So 1, RE1 denotes the equivalent resistance referred to the primary side. Let us also write what it is referring. Equivalent resistance. Equivalent referred to primary. Okay. Similarly, my X E1 will be equal to X1 plus K square X2 will be equal to K square X2. Okay. Now my primary current I1 will be given by V1 upon Z equivalent to 1 will be equal to RE1 plus JXE1. Okay, these are the vector representation. This is a complex form representation, vector representation. So RE1 plus JXE1, always the reactance is denoted by J because it is vector part. Okay, it is depicting the direction also actually. Okay, so the equivalent Z will be equal to ZE1 plus ZL K square will be equal to ZL K square. So here we can put the value ZE1. This is the impedance. ZE1 is the impedance referred to the primary side. ZE1 plus ZL K square. So this is the value of the primary current. This is the value of the primary current. Okay. So this circuit is the complete equivalent circuit. This circuit is the exact equivalent circuit, and this circuit is the approximate equivalent circuit. And if the no load current is very much more smaller and it is having negligible effect on the primary resistance and primary reactances, then we can neglect this part also. No problem. Okay, so that will be also the equivalent. That will be also giving the approximate equivalent circuit only. Now, what are the advantages of approximate equivalent circuit? There are two basic advantages of approximate equivalent circuit. The first advantage is that calculating the impedance is easy, very much easy. Here there are two circuits. The impedance calculation is very much complex. We cannot calculate easily, and we cannot analyze the transformer also easily. But here the impedance can be easily calculated, as I calculated over here. R1, R2, K square R2 easily can be added, and similarly the reactances can be easily added. So the impedance calculation was very much easy. Also the voltage regulation can be easily calculated and can be easily done with the help of approximate equivalent circuit. So these are some advantages of approximate equivalent circuit. So this is all about the equivalent circuit referred to the primary side. So in the next lecture, in the next video, we will be learning about the equivalent circuit referred to the secondary side. Okay, so till then, goodbye, thank you. So please subscribe my channel, please share my videos, and if you have any doubt you can ask me in the comment section. Thank you.